This is the EdExcel A-Level Further Maths Paper 2 covering the Core Pure module, and this is from the 2025 series. Question number 1. Given that z equals 2 subtract 2 root 3i and w equals negative 1 plus root 3i, show that for part A, the mod of z over w is equal to mod of z over mod of w. Let us begin by working out what z over w is. That's equal to 2 subtract 2 root 3i over negative 1 plus root 3i. So if we work out what this is, on our calculator, let us change the settings such that we display the result in the form a plus bi. We have 2 subtract 2 root 3i over negative 1 plus root 3i. It turns out we get negative 2. Hence, the mod of z over w will equal the absolute value of negative 2, which is just 2. Let us now work out the mod of z. That's equal to the square root of 2 squared plus negative 2 root 3 squared, and this is equal to 4. Similarly, let's work out the mod of w. That's equal to the square root of negative 1 squared plus root 3 squared, and that's equal to 2. And so, mod of z over mod of w, that's equal to 4 over 2, which is equal to 2. What we see here then is the mod of z over w is equal to the mod of z over the mod of w, and that of course is equal to 2. Part B. We have to show that the argument of zw is equal to the argument of z plus the argument of w. To begin with, let us work out what zw is. That's 2 subtract 2 root 3i multiplied by negative 1 plus root 3i. We have 2 subtract 2 root 3i multiplied by negative 1 plus root 3i, and it turns out we get 4 plus 4 root 3i. So now we can work out the argument of zw. Let us change the settings such that we display our theta. Four plus 4 root 3i, that is the same as 8 e to the pi I over 3. So the argument of zw will equal pi over 3. Let us now work out the argument of z. We have 2 subtract 2 root 3i, which is the same as 4e to the negative pi I over 3. So the argument of z is negative pi over 3. Let us now work out the argument of w. We have negative 1 plus root 3 I, that is 2e to the 2 pi I over 3. So the argument of w is 2 pi over 3. If we now add together the argument of z to the argument of w, we have negative pi over 3 plus 2 pi over 3, which is pi over 3. And that is what the argument of zw is, pi over 3. Meaning, the argument of zw is equal to the argument of z plus the argument of w, which is pi over 3. Question number 2. An archer shoots an arrow towards a target. In a model, the arrow is a particle, the flight path of the arrow is a straight line, the target is part of a plane, relative to a fixed origin, or the arrow is fired from the point with position vector 3i subtract 5j plus 2k. The plane containing the target has equation 2x plus 4y subtract z equals 3. In this question we have to use the model to answer parts A to D. Part A. Determine the shortest distance that the arrow must travel to reach the plane. We've got this position vector 3i subtract 5j plus 2k, which as a point is 3, negative 5, 2. We've got this plane which has equation 2x plus 4y subtract z equals 3. I'm going to rewrite that as 2x plus 4y subtract z subtract 3 equals 0. We know that the perpendicular distance of alpha, beta, gamma from n1x plus n2y plus n3z plus d equals 0 is given by this formula here. And that of course would be the shortest distance. So for the shortest distance we have the mod of 2 multiplied by 3 plus 4 multiplied by negative 5 subtract 1 multiplied by 2 subtract 3 over the square root of 2 squared plus 4 squared plus negative 1 squared. So let's work this out. We have the absolute value of 2 multiplied by 3 plus 4 multiplied by negative 5 subtract 1 multiplied by 2 subtract 3 over the square root of 2 squared plus 4 squared plus negative 1 squared. It turns out we get 4.15. The arrow hits the target at the point with position vector 6i subtract 2j plus k. Part B. Determine a vector equation of the flight path of the arrow. Well, if we have this vector A and this vector B, we can find the direction vector AB, and as we know that the straight line would pass through this point 6i subtract 2j plus k, we can then form the vector equation of the line. To begin with, we have the vector AB, so that's OB subtract OA. So we have OB 6 negative 2 1 subtract OA 3 negative 5 2, and it turns out we get 3 3 negative 1. As we know the line passes through the point B, we can therefore state R will equal 6 negative 2 1 plus lambda multiplied by 3 3 negative 1. Part C. Determine the acute angle that the flight path of the arrow makes with the target. Give your answer to the nearest degree. let's draw a diagram. We've got this plane pi, and we've got this line L, and perpendicular to pi is the normal vector, which I will call n. What we need to do in this question is work out the angle between the plane pi and the line L, and we'll call that alpha. What we can do to begin with is work out the angle in between the normal vector n and L. We'll call that theta, and cos theta will be given by the direction vector of L, we'll call that d, dot with n over the mod of d times the mod of n. Now we know what this direction vector is. That's 3, 3, negative 1. And what we can do from here is find out what the mod of d is. That's the square root of 3 squared plus 3 squared plus negative 1 squared, which is root 19. If we take a look at the plane pi with equation 2x plus 4y subtract z equals 3, from this we can state what the normal vector is. The normal vector will be the coefficients of x, y and z. That will be given by 2, 4, negative 1. So now we can find the magnitude of n. That's equal to the square root of 2 squared plus 4 squared plus negative 1 squared, which is root 21. We can now work out what d dot with n is. So we've got 3, 3, negative 1 dot with 2, 4, negative 1. We've got 3 times by 2 plus 3 times by 4 plus negative 1 times by negative 1, and it turns out we get 19. And if we substitute all these back into this formula, we can find out what cos theta is. So for cos theta we would have 19 over square root 19 times square root 21. Over square root 19 times square root 21. It turns out we get 0.951, etc. And from this we can find out what theta is. We have the inverse cosine of this value, which is 18 degrees. And so, if we know this is 18 degrees, we've got a right angle between pi and n, we can work out what alpha is. That will be 90 subtract 18, which is 72 degrees. Part D. Determine the distance travelled by the arrow. Well, it starts here at 3, negative 5, 2, and it finishes here 6, negative 2, k. We need to find the distance between those points. You'd recall in part B, we worked out what the vector AB is. That's 3, 3, negative 1. So we need to work out the magnitude of this. So we've got the magnitude of AB equaling the square root of 3 squared plus 3 squared plus negative 1 squared, which is root 19. Square root 19, that's equal to 4.36. Part A. Comment on whether the actual distance travelled by the arrow is likely to match the answer to Part D, giving a reason for your answer. Well, it's not likely to match, and that's because the arrow's flight path is unlikely to be a straight line. Question number 3. We are given the matrix A which is equal to 1502. Part A, proved by mathematical induction that for n belonging to a set of natural numbers, a to the n is equal to 1, 5 times 2 to the n subtract 1, 0, 2 to the n. I think it's a good idea to write down what we want to show. We need to replace the n with k plus 1, and that shows us a target we need to work towards. So we want to show that a to the k plus 1 is equal to 1, 5 times 2 to the k plus 1 subtract 1, 0, 2 to the k plus 1. The first step then would be to substitute in n equals 1. Now what we do with n equals 1 is we substitute it into the left hand side and then the right hand side, and we want to show that the left hand side is the same as the right hand side when n equals 1. On the left hand side we have the matrix A to the power of 1, that will be 1502 to the power of 1, which is 1502. On the right hand side we have 1, 5 times 2 to the 1 subtract 1, 0, 2 to the 1, which is equal to 1502. We see that the result then is true for n equals 1 because the left hand side is equal to the right hand side. The next step is to assume that the result is true for n equals k. Here we would have to replace the n with k, meaning a to the k is equal to 1, 5 times 2 to the k subtract 1, 0, 2k. The third step is to try for n equals k plus 1. So we have a to the k plus 1, and this is what we need to work out. Now using the laws of indices, this is the same as a to the k times a to the 1. We know what a to the k is. We work that out in step 2. That's 1, 5 times 2 to the k subtract 1, 0, 2 to the k. And we know what a to the 1 is. We work that out in step 1. That is 1502. We need to go from here to here. So we have 1 multiplied by 1 plus 5 times 2 to the k subtract 1 multiplied by 0. Then we have 1 multiplied by 5 plus 5 times 2 to the k subtract 1 multiplied by 2. Then we have 0 multiplied by 1 plus 2 to the k multiplied by 0, and then we've got 0 times by 5 plus 2 to the k times by 2. So we've got 1, and then here we've got 5 plus, now here we've got 5 times by 2, which is 10, and we multiply that by 2 to the k subtract 1. Then we've got 0, and then we've got 2 to the k times by 2. So, continuing working this out, we've got 1, and then here we've got 5 plus, now I'm going to multiply the 10 into this bracket, so I've got 10 times 2 to the k subtract 10, then we've got 0, and then we've got 2 to the k times 2 to the 1. 2 is the same as 2 to the 1. So we've got 1, and then what we have is the 10 times 2 to the k plus 5 subtract 10, which is negative 5. Then we've got 0, and then here we've got 2 to the k times 2 to the 1. So we've got 1. Now this 10 I'm going to rewrite as 5 times by 2, and I'm multiplying this by 2 to the k, and then I'll subtract 5. Here I've got 0, and here I've got 2 to the k times 2 to the 1. So I've got 1. Now here I can factorize out 5, and then I've got 2 times 2 to the k, subtract 1, then I've got 0, and then 2 to the k times 2 to the 1. So I've got 1, and then I've got 5 times by 2 to the 1, which is the same as 2, times 2 to the k, subtract 1, then I've got 0, and then 2 to the k times 2 to the 1. And using the laws of indices, we've got 1, 5 times by 2 to the k plus 1, subtract 1, 0, and 2 to the k plus 1. And that is exactly what we wanted to show. Hence, for the fourth step, which is the conclusion step, we state that if it's true for n equals k, then it's true for n equals k plus 1, and as it's true for n equals 1, it's true for n belonging to a set of positive integers. Given the matrix B, which is equal to negative 1, 0, 0, 1, part B, describe fully the single geometric transformation P represented by the matrix B. We've got this matrix B, which is negative 1, 0, 0, 1. If I apply this matrix to a general point xy, we get the point negative xy. And so what's happened is this point has been reflected in the y-axis to get this point, meaning the matrix B would represent a reflection in the y-axis. The transformation Q is represented by the matrix A to the n. The transformation P followed by the transformation Q is the transformation R, which is represented by the matrix C. Part C. Determine the matrix C in terms of n. Here we've got P followed by Q, and that would represent the matrix A to the n followed by B. So the matrix C, that will be given by this matrix 1, 5 times 2 to the n subtract 1, 0, 2 to the n, multiplied by negative 1, 0, 0, 1. So let's work this out. Well, we've got 1 multiplied by negative 1 plus 5 times 2 to the n subtract 1 times by 0. Then we've got 1 times by 0 plus 5 times 2 to the n subtract 1 times by 1. Then we've got 0 multiplied by negative 1 plus 2 to the n times by 0. Then we've got 0 times by 0 plus 2 to the n times 1. So I've got negative 1. Here I've got 5 times 2 to the n subtract 1. Then I've got 0, and then I've got 2 to the n. Given that for a particular value of n, the transformation R maps the point with coordinates 27, 1 to the point with coordinates A, where A is a constant, part D, determine the matrix that represents the transformation Q. So we've got this matrix, negative 1, 5 times 2 to the n subtract 1, 0, 2 to the n. and this is applied to the point 27, 1, and from this we get the point AA. Now let's work out what the left hand side is. We've got negative 1 times 27 plus 5 times 2 to the n subtract 1 multiplied by 1. And then we've got 0 times by 27 plus 2 to the n times by 1. And this is equal to AA. So we've got negative 27 plus 5 times 2 to the n subtract 1 and 2 to the n, which is equal to AA. Now because the x and y are equal, that means we would have negative 27 plus 5 times 2 to the n subtract 1 equaling 2 to the n. On the left hand side we've got negative 27 plus 5 times 2 to the n subtract 5, and on the right hand side we've got 2 to the n. Rearranging, we have 4 times by 2 to the n equaling 32, 2 to the n which is equal to 8, meaning n is equal to 3. In this part of the question we had to determine the matrix that represents the transformation Q, and that's what a to the n is. So we substitute in n equals 3 back into a to the n. So we've got a cubed, which will be given by 1, 5 times 2 to the 3 subtract 1, 0, 2 cubed. So if we work this out, we've got 1, 35, 0, 8. Question number 4. For the first part, we are given that z1 equals a plus bi and z2 equals c plus di, where a, b, c and d are real constants. Given that b is greater than d, z1 plus z2 is real, the mod of z1 is equal to root 13, the mod of z2 is equal to 5, and the real part of z2 subtract z1 equals 2, we have to show that a equals 2 and determine the value of each of b, c and d. If we know that z1 and z2 is real, that means the imaginary part of z1 plus z2 is equal to 0. Let us begin by working out what z1 plus z2 is. z1 plus z2, that's equal to a plus bi plus c plus di. In other words, we've got a plus c plus b plus di, and if we set the imaginary part equal to 0, we would have b plus d equaling 0, meaning d is equal to negative b. We'll call this equation 1. We also know that the real part of z2 subtract z1 equals 2. Let's begin by working out what z2 subtract z1 is. That is c plus di subtract a plus bi. So we have c subtract a plus d subtract b I, and so we set the real part equal to 2, so we've got c subtract a equals 2. If we rearrange this, you will find c to equal a plus 2. We've got the mod of z1 equaling root 13. The mod of z1 that will be given by the square root of a squared plus b squared, and this is equal to root 13. Squaring both sides, we've got a squared plus b squared, which is equal to 13. Let's call this equation 3. We also know that the mod of z2 is equal to 5, so we've got the square root of c squared plus d squared, which is equal to 5, and squaring both sides, c squared plus d squared, that's equal to 25, which I'll call equation 4. Now, we can replace the c with a plus 2, and we can replace the d with minus b. And in doing so, we can form a new equation in a and b. Substituting equation 1 and 2 into 4, we would have a plus 2 squared plus negative b squared equals 25. So we've got a plus 2 squared plus b squared equals 25, which I'll call equation 5. And now we can compare this equation 5 with this equation 3, and if we subtract those, we can eliminate the b squareds. So if I do equation 5 take away equation 3, I've got a plus 2 squared, and then I've got b squared, subtract b squared, and then I subtract this a squared with it. And this is equal to 25 subtract 13, which is 12. So I've got a plus 2 squared, subtract a squared equals 12. Expanding, I've got a squared plus 4a plus 4, subtract a squared equals 12, leaving us with 4a plus 4 equals 12, so a is equal to 2. We now need to find out what b, c and d are. If we take a look at equation 2, that's given by c equals a plus 2, so we can find out what c is. C is equal to 2 plus 2, which is 4. And if I take a look at equation number 3, what we can now do is find out what b is, because we know what a is. Using equation 3, I've got 2 squared plus b squared equals 13. B squared is equal to 9, so b is equal to plus minus 3. I also know that d is equal to negative b. So if I use equation 1, we can find out what the corresponding values of d are. D is equal to negative 3, which is equal to negative 3, or we've got d equaling negative 3, which is 3. Now because b is greater than d, we need the bigger value of b, which is the 3, and that gives us the smaller value of d. So b equals 3 and d is equal to negative 3, and that's because b is greater than d. That means z1 is equal to 2 plus 3i and z2 is equal to 4 subtract 3i. For the second part of the question, for part A, on the same Argon diagram, we have to sketch the locus of point Z which satisfy mod of Z subtract 12 equals 7, and sketch the locus of points W which satisfy the mod of W subtract 5i equals 4, showing the coordinates of any points of intersection with the axis. If we take a look at the first equation, we have a circle with center 12, 0 and radius 7, and if we take a look at the other equation, we have a circle with center 0, 5 and radius 4. And here are those two circles. For this circle we've got a center at 0, 5, and for this circle we've got the center at 12, 0. For this circle we know that the radius is 4, so if I do 5 plus minus 4, I get one of the points where it crosses the imaginary axis at 9 and the other one being at 1. And here I know that the radius is 7, so if I do the center, which is 12, plus minus 7, I get one of the points where it crosses the real axis being at 5 and the other point where it crosses the real axis being at 19. Part B. Determine the range of possible values of the mod of Z subtract W. In this question it would help if we add on what we know. Well, to begin with, we've got this distance, which is the distance between the centres. We've got the radius of 4 shown here, and we've got the radius of the larger circle being 7. The smallest value of mod of Z subtract W will be this distance here, and the maximum will be this point to this point. So to begin with, we can find the distance between the centres, and that will be this length here. That's given by 12 subtract 0 squared plus 0 subtract 5 squared, all square rooted, which is 13. So here we've got 13. What we can now do is find the distance that's here between this circle and this circle, and we can find the distance between this point and this point. That will be the maximum. So for the minimum of mod of z subtract w, that will be this length of 13, take away this radius of 4, and I also take away this radius of 7. That gets me 2. And the maximum of mod of z subtract w, well, that will be this 13 plus this 4 plus this 7, which is 24. So the distance between this point and this point is 24, meaning the mod of z subtract w is greater than or equal to 2, but less than or equal to 24. Question number 5. 3 planes are defined by the following equations. 2x subtract y plus z equals 3, x plus py subtract 3z equals q, 3x plus y subtract 2z equals 4, where p and q are constants. Given that the planes form a sheaf, we have to determine the value of p and the value of q. The first thing we will do is rewrite the system of equations in matrix form. We've got this matrix 2, negative 1, 1, 1p, negative 3, 3, 1, negative 2, multiplied by the vector x, y, z, and this is equal to 3q, 4. Now, we will let the matrix M equal 2, negative 1, 1, 1p, negative 3, 3, 1, negative 2. And we know that the planes form a sheaf. That means the determinant of M is equal to 0. So we need to find the determinant of M from this matrix. So for the determinant of M, we've got plus 2, and then we cover up the first row and the first column, and we take the determinant of what's left over. That would be p, negative 3, 1, negative 2. Then we have minus. Then we've got this negative 1. We cover up the first row and the second column and take the determinant of what's left over, which is 1, negative 3, 3, negative 2. And then we've got plus 1. And then we cover up the first row on the third column and take the determinant of what's left over. That is 1p, 3, 1. So we've got 2 multiplied by, now here I've got p multiplied by negative 2, subtract negative 3 times by 1, plus 1, and that's because we've got negative 1, multiplied by 1 multiplied by negative 2, subtract negative 3 multiplied by 3. And then we've got 1 multiplied by 1 multiplied by 1, subtract p multiplied by 3. Simplifying, we end up with 14 subtract 7p. So, because we know that the planes form a sheaf, so the determinant of M is equal to 0, that means we have 14 subtract 7p equals 0, meaning p is equal to 2. So we can rewrite the system of equations replacing p with 2. For the system of equations, we've got 2x subtract y plus z equals 3. That's equation 1. We've got x plus 2y, remember p is 2, subtract 3z equals q, that's equation 2. And then we've got 3x plus y subtract 2z equals 4, which is equation 3. What we will now do is add together equations 1 and 2. In doing so, we've got 2x plus x, which is 3x, negative y plus 2y, which is y, z subtract 3z, which is negative 2z, and this is equal to 3 plus q, which I'll call equation 4. And if we compare equation 3 with equation 4, you can see on both the left-hand sides of these equations we've got 3x plus y subtract 2z. We know that the planes form a sheaf, so the system of equations is consistent. So if I compare equation 3 with equation 4, I would have this 4 equaling 3 plus q, and that is because the system of equations is consistent, and if I solve for q, q is equal to 1. Question number 6. The quartic equation 2x to the 4 plus ax cubed subtract ax squared subtract 5x plus 6 equals 0, where a is a real constant, has roots alpha, beta, gamma and delta. Before we do anything else, let us divide the equation by 2. In doing so, we have x to the 4 plus a over 2 x cubed subtract a over 2 x squared subtract 5 over 2x plus 3 equals 0. From this, we can state that alpha plus beta plus gamma plus delta, that is negative a over 2, alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta, that will equal negative a over 2, alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta, that will equal negative 5 over 2, which is 5 over 2. Alpha beta gamma delta, that will equal 3. Part A, we have to determine the value of 3 over alpha plus 3 over beta plus 3 over gamma plus 3 over delta. 3 over alpha plus 3 over beta plus 3 over gamma plus 3 over delta, that is 3 times by 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. What this is the same as is 3 times by, well, for the denominators I would have alpha beta gamma delta, and for the numerators I would have alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. And substituting in those values, we would have 3 times by 5 over 2 over 3, which is 5 over 2. Given that alpha squared plus beta squared plus gamma squared plus delta squared is equal to negative 3/4, part B, determine the possible values of A. For part B, we can state that alpha plus beta plus gamma plus delta squared, that is equal to alpha squared plus beta squared plus gamma squared plus delta squared plus 2 times by alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. Substituting the values in, we have negative a over 2 squared, which is equal to negative 3 over 4 plus 2 times by negative a over 2. So we have a squared over 4 equaling negative 3 over 4 subtract a. If I multiply through by 4 and rearrange, we would have a squared plus 4a plus 3 equals 0. Factorising, we have a plus 1 times a plus 3 equals 0, meaning a is equal to negative 1, a is equal to negative 3. Question number 7. The curve C, shown in figure 1, has polar equation r equals a times by 1 plus sine theta, where theta is in between negative pi and a is a constant. The tangents to C at the points A and B are perpendicular to the initial line. Let's show this on the diagram here. Part A, use calculus to determine the polar coordinates of A and B. To begin with, we have x which is equal to r cos theta, and we know what r is, that is a times 1 plus sine theta, so we've got a times 1 plus sine theta multiplied by cos theta. We now have to find out what dx over d theta is because we are focusing on the vertical tangents, so we need to differentiate this. Now if I take the a on the outside, we can use the product rule to differentiate this. We have v times by u dash, which is cos theta, plus u, which is 1 plus sine theta, times by v dash, which is negative sine theta. So we have a multiplied by, now here we've got cos squared theta, and then I've got negative sine times by 1, that will be negative sine theta, and then I've got negative sine theta times by sine theta, so that's negative sine squared theta. So I've got a times by, now the cos squared I can replace with 1 subtract sine squared, so I've got 1 subtract sine squared theta, subtract sine theta, subtract sine squared theta, multiplied by a, which is a times by 1 subtract 2 sine squared theta, subtract sine theta. We now have to set this equal to 0 because we are focusing on the tangents being perpendicular to the initial line. If we divide through by a, we will be left with 1 subtract 2 sine squared theta subtract sine theta equals 0, from which we would have sine theta equaling 1/2 and sine theta equaling negative 1. From sine theta equaling 1/2, we would have theta equals pi over 6 and 5 pi over 6. And from sine theta equaling negative 1, we would have theta equaling negative pi over 2. This will be the pole. Now, we know that r is equal to a times by 1 plus sine theta, and we know that we've got theta equaling pi over 6 and 5 pi over 6, which corresponded to sine theta equaling 1/2. So we can find out what r is. R will equal a times by 1 plus sine theta, and sine theta is 1/2, and that will equal 3a over 2. So the coordinates for a, that will be 3a over 2 pi over 6, and the coordinates of b will be 3a over 2 5 pi over 6. The curve C models the perimeter of the surface of a swimming pool. Given that according to the model the distance across the pool from A to B is 10 meters, part B show that A equals 20 root 3 over 9. We know that x is equal to r cos theta. So if I find out what xa is, that will be r, which is 3a over 2, times by cos theta, so we times this by cos of pi over 6. So I've got 3a over 2 times by root 3 over 2, which is 3a root 3 over 4. And we can also find out what xb is. xb, that will equal 3a over 2 times by the cosine of 5 pi over 6. So we've got 3a over 2 times by negative root 3 over 2, so that's negative 3a root 3 over 4. We know that y is equal to r sine theta. Now, ya will equal yb because sine theta will equal 1/2, and r is the same. So we've got 3a over 2 times by sine theta, which we know is 1/2, so we get 3a over 4. So AB, that will equal 3a root 3 over 4, subtract negative 3a root 3 over 4, which is 3a root 3 over 2. So we set this 3a root 3 over 2 equal to 10, and solving for a, you will find a to equal 20 root 3 over 9. Part C. Use algebraic integration to determine the surface area of the swimming pool according to the model. We know that the area is given by a half times the integral of r squared d theta. So the area is given by a half times by the integral of a times 1 plus sine theta squared d theta, and we evaluate this from minus pi to pi. So we have a half times by a squared, which is then multiplied by the integral from negative pi to pi of 1 plus sine theta squared d theta. So we've got a squared over 2 times the integral from minus pi to pi of, now 1 plus sine theta squared, that is the same as 1 plus 2 sine theta plus sine theta squared. So we've got a squared over 2 times the integral from minus pi to pi of, well, we've got this 1 plus 2 sine theta, and we add on sine theta squared, which is the same as adding on 1 subtract cos 2 theta over 2. So we've got a squared over 2 times the integral from negative pi to pi of, now here we've got 1 plus a half, which is 3 over 2. We add on to this 2 sine theta, and then we subtract cos 2 theta over 2. Knowing what is, which is 20 root 3 over 9, we square this and we times this by half, and then we multiply this by the integral from minus pi to pi of 3 over 2 plus 2 sine theta subtract cos 2 theta over 2 d theta. So let's work out what this is equal to. We have 20 root 3 divided by 9 squared times 1 half, which is 200 over 27. So we multiply this by the integral from minus pi to pi of 3 over 2 plus 2 sine theta subtract cos 2 theta over 2 d theta. So I've got 200 over 27, and now if I integrate, I've got 3 theta over 2, subtract 2 cos theta, subtract sine 2 theta over 4, which I need to evaluate between minus pi and pi. So I've got 200 over 27 as a common factor, and then for the upper limit I've got 3 pi over 2, subtract 2 cos pi, subtract sine 2 pi over 4, and I subtract from this lower limit, which is 3 times negative pi over 2, subtract 2 cos of negative pi, subtract the sine of negative 2 pi over 4. So let's work this out on our calculator. We have 3 pi over 2 subtract 2 cos pi subtract the sine of 2 pi over 4. And we then subtract from this 3 times by negative pi over 2, subtract 2 times by the cosine of negative pi, subtract the sine of negative 2 pi over 4, and then I times this by 200 over 27, so we get 69.81 etc. meters squared. Question number 8. Given that y equals cos x times hyperbolic sin x, where x is a real number, for part A we have to show that the fourth derivative of y with respect to x is equal to ky, where k is a constant to be determined, and then for the next part of the question we would have to determine the first three non-zero terms of the Maclaurin series for y, giving each coefficient in simplest form. We begin with y, which is cos x times by hyperbolic sin x. The first thing we will do is we will find y of 0. That's equal to cos of 0 times by hyperbolic sin of 0, which is 0. We can now find out what dy over dx is. We can do this using the product rule. We have v, which is hyperbolic sin x, times by u dash, which is negative sin x, plus u, which is cos x, times by v dash, which is hyperbolic cosine x. So now if I find the value of y dash when x is 0, we would have hyperbolic sine of 0 times negative sine of 0 plus cos of 0 times by hyperbolic cosine of 0, which is 1. Let's now find the second derivative. If I focus on the hyperbolic sine x times by negative sine x, we would have v, which is negative sine x, times by u dash, which is hyperbolic cosine x, plus u, which is hyperbolic sine x, times by v dash, which is negative cos x. And now if I focus on the cos x times by hyperbolic cosine x, we would have v, which is hyperbolic cosine x, times u dash, which is minus sine x, plus u, which is cos x, times by v dash, which is hyperbolic sine x. And the negative cos x times hyperbolic sine x and the cos x times the hyperbolic sine x cancel, leaving us with negative 2 times by sine x times by hyperbolic cosine x. So now if we find the second derivative when x is equal to 0, we've got negative 2 times by the sine of 0 times by hyperbolic cosine of 0, which is 0. Let's now find the third derivative. Well, I've got this negative 2, which I'll leave on the outside, and then I'll use the product rule. So I've got v, which is hyperbolic cosine x, times by u dash, which is cos x, plus u, which is sine x, times by v dash, which is hyperbolic sine x. So now if I find the value of the third derivative when x is 0, I've got negative 2 times by hyperbolic cos of 0 times cos of 0 plus sine of 0 times hyperbolic sine of 0. And it turns out we get negative 2. Let's now find the fourth derivative. For the fourth derivative, well, I've got this minus 2. And if I differentiate the hyperbolic cosine x, cos x first, well, I've got v, which is and then I've got the derivative of plus cos x times by the derivative of hyperbolic cos, which is hyperbolic sine. and then I've got to differentiate sin x times hyperbolic sin x. So I would have hyperbolic sin x times by cos x plus sin x times by hyperbolic cos x. The negative sin x times by hyperbolic cos x and the sin x times hyperbolic cos x cancel, leaving us with negative 2 times by cos x times hyperbolic sin x. So I've got negative 4 times by cos x times hyperbolic sin x, and cos x times hyperbolic sin x, that is what y is. So I've got negative 4y. So now let's find the fourth derivative when x is 0. So I've got negative 4 times by y of 0. So I've got negative 4 times by 0, which is 0. For the fifth derivative, that will be negative 4 times by the differential of y with respect to x, in other words dy over dx. So I've got negative 4 times by dy over dx, and we've already worked out what dy over dx is, that's shown here. So I've got negative 4 times by hyperbolic sin x times negative sin x plus cos x times hyperbolic cos x. And now if I find the value of the fifth derivative when x is 0, I've got negative 4 times by y dash of 0. Y dash of 0, I know that is equal to 1. So I've got negative 4 times by 1, which is negative 4. Now for a Maclaurin series, we've got f of x, which is equal to f of 0 plus x times f dash of 0 plus x squared over 2 factorial times f double dash of 0, so on and so forth. And generally we would have x to the r over r factorial times the rth derivative of f when x is 0. So I've got y, which is equal to y of 0 plus x times by y dash of 0 plus x squared over 2 factorial times y double dash of 0 plus x cubed over 3 factorial times y triple dash of 0 plus x to the 4 over 4 factorial times y 4 of 0 plus x to the 5 over 5 factorial times y 5 of 0 plus higher order terms. Y of 0 is 0, y 2 is 0, y4 is 0, leaving us with x times y dash of 0 plus x3 over 3 factorial times y3 when x is 0 plus x to the 5 over 5 factorial y5 of 0 plus higher order terms. So I've got x times by 1 plus x cubed over 3 factorial times negative 2 plus x to the 5 over 5 factorial times negative 4 plus higher order terms. So I've got x subtract x cubed over 3 subtract x to the 4 over 30 plus higher order terms. Question number 9. We are given that y is equal to the arc sine of 3x, where x is in between negative 1/3 and 1/3. Part A, we have to determine dy over dx in terms of x. We know that the differential of arc sine x is equal to 1 over the square root of 1 minus x squared. Using the chain rule then, dy over dx, that will equal 1 over the square root of 1 subtract 3x squared times by the differential of 3x, which is just 3. So we end up with 3 over the square root of 1 subtract 9x squared. The curve C has equation y equals cos of the arc sine of 3x, where x is in between negative 1/3 and 1/3. Part B, determine dy over dx, giving your answer in simplest form. For dy over dx, well, if I differentiate cos, I get minus sine. So I've got minus sine of the arc sine of 3x, and then I have to differentiate the bracket. The differential of the arc sine of 3x, we've worked out in part A, that's 3 over the square root of 1 minus x squared. Now, negative sine of the arc sine of 3x, that's just negative 3x, and I times this by 3 over the square root of 1 minus 9x squared. So I end up with negative 9x over the square root of 1 minus 9x squared. Part C, hence determine the x-coordinate of the point on C at which the gradient is 4. So we've just worked out what dy over dx is, and we have to set that equal to 4. So I've got negative 9x over the square root of 1 minus 9x squared equals 4. Multiplying through by the square root of 1 minus 9x squared, we end up with minus 9x equals 4 times by the square root of 1 minus 9x squared. If I square both sides, I've got 81x squared equals 16 times 1 minus 9x squared. So I've got 81x squared equals 16, subtract 144x squared. Rearranging, I've got x squared equals 16 over 225, which means x is equal to plus minus 4 over 5. Now, if I think about this minus 9x over the square root of 1 minus x squared, this will be greater than 0. The reason for that is because this is equal to 4, and 4 is of course greater than 0. So I've got minus 9x, which is greater than 0, and if I divide both sides by minus 9, I would have x is less than 0. So if x is less than 0, I need to take the negative value of this, meaning x is equal to negative 4 over 5 only.